Before we go to mathematics, we need to look at the short syllabus of mathematics too. What are the chapters that are there for us?
Wait, sir, I know them.
2, 3, 7, 8, and 9, and 11, and 16, and 17. Wow, so many. So the first one is going to be chapter 2. Set and function. Set and function. 24. And this is set. What is a set? Can anybody tell me? Onbor Onon Saha, or is it Anbar Anand Saha? What's your name, little boy? Am I saying your name right? Anbar Onon Saha, or is it Onbor?
It's Anbar Anand Soha. You can call me Soha.
Soha. Anbar Onon Soha. I thought you are
Anand Soha.
Anan. Sorry.
Yeah. No,
Anbar
it's okay.
Anan Soha. I can call you Soha. Soha, thank you for mentioning the chapters in maths. So let's get to business. Sets. Can anyone tell me any sort of idea about sets? And then we'll start. Anyone? Actually, set is a
I think set is a group of natural numbers.
not really always natural numbers. Not just natural numbers. Set
Imaginary
is
numbers.
like
Set is a well-organized object of real or imaginary world.
did you just read this one, Soha?
Yeah, I actually got the book today.
It's okay, no problem. Thank you for saying it to us. Set, like it's written here, is a well-organized object of real or imaginary world. I'm not really okay with this definition. It still leaves so many doubts in our minds. What does a well-organized object mean? Real or imaginary world? What does it mean? It's not really clear. So let me make it clear for you. Set, forget about mathematics. Like in your common language, if we say set, what does it mean? Like if I tell you, I have a set of books in my bookshelf, a set of books in my bookshelf, right? If I tell you something like this, let's say this is my bookshelf and I have two different columns of books. This is one set of books, let me call it A, and this is one set of book. Let me call it B. So 1, 2, 3, 4. 4 books in column A and like 5, 6, 7, 8. So I have two sets of books in my bookshelf. Can we say it like this? Forget about mathematics, just common sense. Two sets of books in my bookshelf. Is it okay to say something like this or not? Class, you have to respond.
Yes, it is.
It is okay. So just like that, in maths, you have to understand when we're talking about sets, set is actually a way of putting same sort of things inside some sort of a category. But when you're talking about sets, you have to put the same things. Like in my set of books, we're talking about books. You can't say I have two sets of book pens. Something like that does not exist. You can say that I have two sets of books and another two sets of pens. So these two or four sets becomes different things, right? So when we are talking about a set, the things that will be included in that set are of the same type. So if it's books, if it's books. If it's pen, if it's pens, it's pens. Like if it's numbers, numbers. If it's this, it's this. If it's that, it's that. But it has to say the same type. That's what a set means. And when it comes to math, how do we express a set? It's a very simple thing. We use what's this symbol called?
Second bracket.
Second bracket. Very good. So if I say that Ahnaf has, how do we get a set out of Ahnaf? Like, let's say that Ahnaf has three different shirts. One is of the color red, one is of the color green, and the another is of the color white. So Ahnaf has three different shirts. One is red colored, one is green colored, and the other one is white. So let's say we put them in a set. Red, green, white. See? And there's a comma here. So in every element, after every, not in, sorry, after every element, we have to put what? A comma to differentiate the elements of a set. These are all the elements of a set. What? Element. Elements of a set. All right, did we get the understanding of the set? It's a very simple thing. Whatever it is included, whatever it is that you are including in a set, it has to be of the same type. Like if I say that Ahnaf's shirt have three different colors, red, green, and white, but Ahnaf's pants or trousers are of another different colors, like yellow. Ahnaf, do you have yellow colored trousers?
No, sir.
Let's say you have yellow, blue, and orange. So this has to be a different set. If we are to include these things in a set, this has to be a different one. It cannot be put in this set because there are two different things. One is the color of the shirts of Ahnaf, and these are the colors of Ahnaf's pants or trousers. So they are going to be in a different set. So whenever you're talking about set, it has to, the elements that are going to be there in a set has to be of the same type. Cannot be two different things or three different things or more. It has to be a single type of things. Got it? Did we get it?
Yes, sir.
So let's look at some of the methods for expressing sets. Sets can be expressed using two methods, namely roster method or tabular method. So one method has two different names, roster or tabular, and the other one is a set builder method. So either it's going to be a roster method or a set builder method. What about the roster method? The roster method is the one method that I have just shown you using a second bracket. You use the second method, and this is called a tabular method or a roster method. Any confusion with that? Any confusion at all? Please let me know.
No, sir.
No, sir. Then we have the set builder method. What's the set builder method? In this method, all elements are not listed. So they're not listed. Rather, their common property is described. For example, A is equal to X. How do we read this symbol right here? Can you see this is a colon. X colon. How do we read it? Can anyone tell me? Any bright, brilliant student in my class who has already studied set? Anyone? Achha, if you're not there,
X is to
X is to not
no
really.
is to something like that.
X such that.
Oh yeah, such that. Yeah,
The right way to
I'm
say
confusing it. Another.
such that. What does such that mean? Such that is stating the property of X. So X has the following properties. So instead of saying following properties, we are saying such that. Okay? So X such that X is an odd natural number. So this is a set of odd natural numbers. How is this set going to look like? A is equal to, what is the first odd natural number? Can anyone tell me?
Sir, 1.
1, and then 3, and then 5, and then 7, and it's going to go on like this. Because we have not limited any fixed range, like odd natural numbers, but they are less than 15, something like that. So the range of this particular set is not given. It's up to infinity, because you can state all sorts of odd natural numbers, and you're gonna die, but the numbers are not gonna finish, right? Or does anyone have a doubt? Can you count all the odd numbers in your lifetime? Is it even possible? Does anyone else have a doubt? Like, you can count those numbers? Can you?
No,
Can you?
sir.
Of course not. Let's look at the second one. B is equal to X such that X is the first 5 students of class 9. So let me rub this thing out. Class 10. So what are my first 5 students? Anav, Soha, and then Naushin, Wadia, Saiba. Is that all? So that means I don't even have 5 students in my class. Such a shame. It's okay. The number of students will increase, inshallah. So if we just the names that I just mentioned, like Soha, and then Ahnaf, and then what? Wadia or Noshin, and then the other guy, Shudipto. This is set B, right? So this is giving us an idea about the elements that will be listed under the set B, the common property. But it's not only stating the elements like Soha, Ana, Wadia, Shudipto. These are the elements. But what this set builder method is doing to us, it's telling us the properties, the common properties that is going to be there in the elements. This is one way of describing a set or expressing a set. Got it? Got it? No one is saying anything. Did we get it?
Yes, sir.
Yes, you got to say it like that. Now, there are 2 examples. One I will solve for you. The next one you got to do yourself. I will ask any of you to do it. Express A is equal to 7, 14, 21, 28 in set building method. How do we do it? Pretty simple thing. They're all multiples of 7, right? Aren't they? They're all multiples of 7. 7 multiplied by 1 is 7. 7 times 2 is, sorry, 7 times 2 is 14, times 3 is 21, times 4 is 28. So they are all multiples of 7. That's one property. Multiples of 7. But they are what? Less than or equal to 28. Sorry. Yes. Less than or equal to 28. Can't be greater than, because there is no value greater than 28. 28 is the last one. So they're all multiples of 7, and they are less than and equal to 28. So how do we write it down? A very simple thing. We have to say A is going to contain, say, X is an element of A, such that X is a multiple of 7. X such that X is a multiple of 7, and X has to be less than or equal to 28. Then we put the bracket. Isn't it very easy, guys? Did we understand this?
Yes, sir.
And there's a slightly different way of expressing it in our book. It said x is a multiple of 7 and x is greater than 0 but less than or equal to 28. So we don't have to say 0 and 28. We can just say that x is less than or equal to 28. Why? Because we've already said they're going to be multiples of 7. So these are the multiples of 7, right? 7, 14, 21, 28. You have to go in this direction. And as soon as you get to 28, you can't go further because the condition is already there. And it has to be less than or equal to 28. So you don't have to say it like that. As soon as you say multiple of 7, you can just say x is less than or equal to 28. No problem. It's done. So did you get the difference between these two answers? Did you understand? Yes, no, gotta tell me.
Yes, yes.
Thank you. All right. Like I said, example 1, I will do for you. Example 2, someone from you guys have to say. Express B. So this was the set building method for us. Now you got to do something using roster method. Express B, where B is equal to X such that X is a divisor of 28. Divisor of 28. How do you find the divisors of 28? What's the method? Can anyone tell me? 28 is our number. Find the divisors for me then. How do we do it? Anyone? No one is interested?
Sir, we have to find the factors of 28.
Yes. Obviously, we're going to start with 1. So 1 into 28. 2 into 14. And then can't use 3. 28 is not divisible by 3. So we use 4 times 7. And that's it. These are all the factors of 28. So B is equal to 1, 2, 4, 7, 14, 28. Right? Let's go down. Did we get it right? 1, 2, 4, 7, 14, 28. Yes, we got it right. So class, did we get this? Did we understand?
Yes, sir.
Okay. Let's go down then. Express C. It's a bit slightly difficult one. Express C where express C such that x is positive integer and x squared has to be less than 18. So positive integers are going to begin with what? 0? Is it? Is 0 a positive integer? Like here, they're starting with 1. Can we put 0 here? And if not, why? We know integers are full numbers, whole numbers, which cannot be expressed in fractions. So 0 is obviously not a fraction, right? But they're saying positive integers. 0 is not a positive number. 0 is neither positive nor negative. It's a type of its own. 0 is 0. It's not a positive one, it's not a negative one. If any number is greater than 0, then it becomes positive. If any number is less than 0, it becomes negative. So 0 is sort of a reference point, like we discussed in physics. 0 is sort of a reference point with respect to which we measure the positivity or the negativity of a number. Just like we use a reference point to understand the motion or this rest of an object. So like you see here, I'm just sort of making a coordination between physics and maths. So 0 is not a positive integer. So it's we got to start with 1. 1 squared is 1, that's less than 18. 2 squared is 4, that's less than 18. 3 squared is 9, still less than 18. 4 squared is 16, that's less than 18. 5 squared becomes 25, which is greater than 18. Right? So 5 is not going to be in set C. So the integers that's going to be there is 1, 2, 3, and 4. Pretty simple. Now there's another thing for you here. Finite set and infinite set. Finite sets are the ones where the elements are going to be fixed, like X, Y, Z. 3 to 60. Here, all the elements are not mentioned, but you know that it's going to like 3, 6, and 9. You get it like this. These are the multiples of 6, multiples of 3. But multiples of 3 up to what? Up to 60. Multiples of 3 up to 60. This is the boundary of this set. It's not going to go beyond 60. There is a boundary. There is some sort of a limit to it. It's not limitless. It's not up to infinity. But if I try to express the same set but in a different way, like multiple of 3, find a set where well, let's say A is a set where A is equal to X such that X is a multiple of 3. X is a multiple of 3. This is going to be an infinite set because 3, 6, 9, 12, and it's going to go on up to infinity. Because you can, oh no, not a first bracket. It has to be a second bracket. Sorry. Second bracket. So 3, 6, 9, 12, and then it's going to go up to infinity. Or if I tell you like set of natural numbers up to infinity, set of integers up to infinity, set of negative integers up to infinity, right? There is no limit. There is no particular end point where you can say this is the last element of this particular set. Or like this set has 4 elements, this set has 5 elements, this set has 60 elements, this set has 100 elements. Number of elements are going to be fixed. When they're going to be fixed, that's finite. And when they're not fixed, that's an infinite set or infinite set. Did we get it? Yes, no, gotta tell me.
Yes, sir.
Okay. Let's look at example 4. Prove that the set of all natural numbers is an infinite set. Very easy to prove. Let's look at the solution. Suppose the set of natural numbers n. Let's say that we are designating the set of natural numbers with this letter n. And it is let's assume, we know that it's not a finite set, but let's just assume for the sake of assuming that n is a finite set. Then this set must have a maximum element k, 100%, right? There has to be a limit, like I told you. There has to be a limit. What does this symbol mean? Can anyone tell me? This symbol, like an E, but not really E. More carved than E. What does this symbol mean? This symbol means
Sir, element of
or belongs to. Has the same meaning. You can say element of, belongs to or element of. So here k is an element of n or k belongs to n. Sir, how do you exactly pronounce finite and finite, or do you just pronounce it depending on the accent you follow? I'm not really sure what the British pronunciation of finite or of this word finite is, or even the American pronunciation. Is it finite? Let's give it a check. Good point, Soha. Let's give it a check. Let's see what Google has to say about finite and finite.
Finite.
Did you hear the pronunciation, class?
Yes, sir.
So it's finite according to British pronunciation, but if I change it to American, what will it be? Let's see. Finite. American pronunciation. Acha, I have found the pronunciation for both the American. This is the British one.
Finite.
It's finite. Oh, no, sorry. This is not the British one. This was the American one.
Finite.
This is the American one.
Finite.
Finite. Same. So finite is the accurate pronunciation then. So how did you get your answer? So how just say yes or no in the chat box. That will be fine. Yes, sir. Okay. So thank you for, we got to learn the pronunciation. Finite, not finite. Finite. Thank you for clarifying this for our class, Suha. So K, let's say K, let us assume that K is the maximum element, although we know there is no maximum element in the set of all natural numbers. There is no maximum element, there is no limit. But let's assume that there is a maximum element and it's K. And K belongs to, or K is an element of N. N is a set. However, according to the concept of natural numbers, if K is a natural number, then K plus 1 is also a natural number which is greater than K, right? Because if we know natural numbers increase by 1, right? Say 15 is a natural number. So 15 plus 1 or 16 is also a natural number. You have to just add 1 to the number to get the next greater value, the next consecutive value of natural numbers. You just have to add 1. We know this by theory that if K is a natural number, then K plus 1 must also exist, which is also a natural number. And thereby K plus 1 should also belong to what? N, right? So if K is an element, K plus 1 also has to be an element because K plus 1 is also a natural number. But initially we assume that K is the maximum element, right? But as we can see, based on the concept of natural numbers, K plus 1 should also exist, which is also a natural number. And in this way, K plus 2 and K plus 3, all of those will exist, which are natural numbers. And they are also going to be included in the set N, right? So there is no limit. There is no such thing as a maximum natural number. It doesn't exist. And therefore, the set of natural numbers N can never be finite. It has to be infinite. Okay. Now, let's look at these examples. Class, you have to tell me. Number 2, is it a finite set or an infinite set?
It's infinite set.
Finite set. What about number 3? Not Anaf,
Num
not Anaf. Anyone else, please give it a try. Number 3, is it a finite set or is it
Sir, infinite.
infinite? Right, because they are increasing to the power of 3. So the power of 3 here is 1, then 2, then 3, then 4, 5, 6, 7, 8, infinity. Okay. What about this one? X such that X is an integer and X has to be less than 4. Is it finite?
Sir, finite.
Yes. Can you express this in the tabular form? Less than 4. So obviously 1, 2, 3, 4. No, not 4. Less than 4. Where did I get mine? Oh, this is a very tricky question. Actually, it's not a finite set because X is an integer. And integers can be positive or negative. So 3, 2, 1, you got to include minus 1 here, 0 and minus 1. And then minus 2, minus 3, up to minus infinity. Because this is an integer. Integers can be positive, both positive and negative, right? Do we know this? Do we know what an integer is, class?
Yes, sir.
So integers can be both positive and negative. And here it said X is an integer. It's not said that X is a positive integer. So less than 4, it can be like 3, and then 2, and then 1, then 0, minus 1, minus 2, minus 3, up to minus infinity. Infinity is the negative direction, right? Because there are infinite number of numbers in the negative direction, right? So actually number 4 is not a finite set. It's an infinite set. This was a trick question. What about number 5? Is this a finite one? This is actually the definition of rational numbers. Rational numbers. Because all rational numbers are expressed in P by Q form, where P and Q are mutually co-primes. Co-primes means they have no common factor between them. No common factor other than 1. Like 2 by 3, or 5 by 7, or 13 by 7. They are mutually co-primes because they have no common factor in between them other than 1. That's the only common factor. Only common factor. Other than 1, there is no common factor in these fractions. So any number which can be expressed in this way, and where Q has to be greater than 1, Q cannot be 1, Q has to be greater than 1, they are called rational numbers. And the set of rational numbers extends up to infinity in both direction, positive and negative. So number 5 is also not a finite set. Did we get this understanding of number 5, or was it a difficult one? Please, class, respond. Did we get it?
Yes, I got it.
Okay. Next one, last one. Y such that Y belongs to the set of natural numbers. N is the set of natural numbers, right? We already saw it. And Y square will be less than 100, but Y cube, beg your pardon, sorry, Y square has to be greater than 100, but Y cube has to be less than 100. So it can be 11, right? 11 squared is 121. Oh, no, greater than, I thought it was less than. Sorry. Y squared is less than 100. So 1, 2, 3, 4. They are all numbers whose square is less than 100. But the cube one has to be greater than 100. Square is less than 100, but the cube is greater than 100. So none of these numbers, 1 cube is 1, 2 cube is 8, 3 cube is what? What's 3 cube? 27. 4 cube is 64. 5 cube is 125. There you go. We found one. So 5 is included here. 6 cube is 36 times 6. 6, 36. 3 times 6, 18. 216. No. 6 cube is not less than 100. So the only natural number that belongs to this category will be 5. That's it. It has just one element. Or is it? Y cube is greater than 100. Oops. Sorry. It is greater than 100. So 6 is there. Let me put it in a simpler way for you. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 squared is 1, 1 cube is also 1. 2 squared is 4, 2 cube is 8. 3 squared is 9, 3 cube is 27. 4 squared is 16, 4 cube is 64. 5 squared is 25, then cube 125. 6 squared is 36, cube 216. 7 squared is 49, and then 7 cube is 49 times 7. 56, 5, 533, 336. Then 8 and 9 will be there. Because obviously the cube of 18, 8 will be greater than 100. So 5, 6, 7, 8, 9, 10. This is the answer. So this is a finite set or a non-finite set.
Find it.
Class, is there only Anaf in there? Rest of the people, please respond.
Sir, finite.
It's a finite set and not an infinite set. Okay? So that's where we're going to conclude. I am sorry, I took 4 minutes of extra time. We're supposed to finish this class by
No problem, sir.
9:50. This is 9:54. I took 4 minutes of your time. So we will meet again, inshallah, on next Monday. Till then, be healthy, be fine. Okay?
Assalamu alaikum, sir.
Wa alaikum
Assalamu alaikum,
assalam.
sir.
And assalamu alaikum to you.